Good evening to all. Yeah, welcome to Unacademy. In case if you are new to this session, please don't forget to like and share the session. We have seen almost 6 lectures before this lecture, and we have now sufficient knowledge to understand what is regular language, right? हर regular language के लिए you can design a finite automata which is either DFA or NFA. You can also represent using regular expression. Good evening, each and everyone, like Sidra, Siddhi, Pavan, and Prashant, Vamshi, whoever joined this session. Very good evening. We have seen a lot of regular languages how to construct these machines. Now in this session also we'll design the machines. At the same time, यहाँ पर हम construct करेंगे conversion वाला. जैसे आपको NFA पता है, DFA कैसे convert करना है, right? एंड आपको NFA विथ एप्सिलॉन मूव्स पता है, DFA कैसे NFA कैसे कंस्ट्रक्ट करना है. तो विल ट्राई टू अंडरस्टैंड ऑल दिस कन्वर्जन्स इन दिस लेक्चर. जैसे आपको पता है यार, इन केस इफ यू हैव नॉट visited my profile, you can use this URL to visit my profile, and don't forget to click on follow, okay, so that you can get everyday notifications whichever the classes I take on Unacademy. And this time Unacademy has produced a lot of good ranks which are now, I'm showing only one ranks, but you have a lot of other ranks to see. Now you have monthly scholarship test for GATE 2025. आपको ये जो टेस्ट अटेम्प्ट करने से आपको ये क्या मिलेगा, आपको 50% स्कॉलरशिप गारंटेड फॉर द टॉप 5 रैंकर्स टू विन 100% स्कॉलरशिप. तो ये दोनों आपको एडवांटेजेस है. तो 50% स्कॉलरशिप भी होगा और टॉप 5 को 100% स्कॉलरशिप होगा, एंड मंथली फ्री टेस्ट होगा. तो आपको इस मंथली फ्री टेस्ट में 20 प्रैक्टिस क्वेश्चंस होगा और ड्यूरेशन 30 मिनट्स है. ये 11 AM 22 जून को होगा. ठीक है, you can apply to this test, and you may avail that if you get top 5 ranks, you may get the free subscription. Yes, if you have any doubt, you can contact this number, they may help you. Yeah, there are so many batches which have started from 38th May. In case if you have already taken the subscription, आप जल्दी enroll कर लीजिए. Just click on this button so that every day class notifications will be coming to you. Okay, so all these batches are started from 38th May. You can join any batch to learn. And test series is already launched on Unacademy. So as per your learning, you can start giving the test. And this test is 1499. Use the code CSDA to avail this offer. So CS test series and data science test series both are available individually at 1499. Okay. A simple test होगा प्रशांत. You can just attempt it, you will understand. Okay. Yes, mathematics and aptitude, very basic test होगा. Or yes, you have this time NFA conversion, and we have seen last class NFA DFA construction. Now along with this construction we'll be seeing DFA versus NFA. तो यहाँ पर आपको NFA होगा, कोई कंस्ट्रक्ट किया होगा, so that you can convert into DFA somehow. So first we'll try to understand these two, right, DFA versus NFA. ये हम कंस्ट्रक्ट किया है, फिर भी हम दोनों कंस्ट्रक्ट करने के लिए कोशिश किया था लास्ट क्लास में, और इस क्लास में सेम DFA वर्सेस NFA होगा, एंड एट द सेम टाइम कन्वर्जन फ्रॉम वन मशीन टू अदर मशीन. तो सबसे पहले हम ये देखेंगे व्हाई डू वांट टू कन्वर्ट, राइट. तो NFA है और DFA है, व्हाई डू वांट टू कन्वर्ट? Any idea? Why do you want to convert? Sometimes designing DFA could be harder. So what do? You will construct NFA, then you can convert to DFA. So that's one advantage. क्यों DFA में क्या होता है, फ्रॉम एवरी स्टेट फॉर एवरी इनपुट सिंबल यू शुड कवर एग्जैक्टली वन ट्रांजिशन। तो यहाँ पर आपको कंसिडर करने के लिए बहुत टाइम लग सकता है, इसी की वजह से हम NFA कंसिडर करके DFA में कन्वर्ट कर सकते हैं। तो ऐसे कोई प्रॉब्लम है क्या, NFA इजी होता DFA डिफिकल्ट होता? तो यह बहुत सारे प्रॉब्लम्स है ऐसे, डायरेक्टली DFA कंसिडर करने में टाइम लग सकता है, राइट। तो यहाँ पर एक दो प्रॉब्लम देखेंगे यार, NFA क्यों इजी होता है, DFA कभी कभी टाइम क्यों लगता है, ठीक है। तो in case if you know how to convert, then you can easily do it NFA to DFA, right? Why we don't convert DFA to NFA? Of course you can, but no need. Why? Because every DFA is NFA. This is by definition only you can understand. By definition every DFA is NFA, that means algorithm exists. ये जो algorithm है ये नाम है subset construction, a special algorithm है subset construction. Using this algorithm you can convert every NFA to DFA. इसलिए हम कहते हैं every DFA is equivalent to NFA because every DFA there is NFA, every NFA there is a DFA. तो अगर दोनों साइड कन्वर्जन है you can always say DFA and NFA are equivalent but they no need to be same. Remember that they may not be same but they are equivalent, even though they can look different, but you can convert one to other. Correct? You can convert one to other. Every DFA you can convert to NFA by definition because every DFA already NFA, and NFA is you can convert into DFA, but NFA need not be DFA. Path clear? Hello. Now we'll see why do we prefer NFA sometimes. Let's see some problems to understand. I'm taking a problem. Look at this. L is equal to second symbol. Let's take second symbol. Yes, third symbol from begin is A. Now, if you want to convert, if you want to construct a DFA, and if you want to construct NFA, almost both look simpler for this problem. Yes or no? DFA, how do you convert or how do you construct? First symbol anything, second symbol anything, but third symbol must be A. Then after that any sequence is fine, and third symbol should not be A. That is why we'll go to trap. And if you delete this one, the remaining is just looks like NFA. NFA is almost same, but NFA how many states you require? Just you require 4 states. DFA require 5 states. So in NFA you can design second symbol, third symbol. That's it. Very simple, no? Got it? Both look simpler, and for this kind of problems you prefer DFA or NFA, it's fine because both look simpler, correct? But when do you need NFA? When do you need NFA? Next problem. In case if you are looking for the third symbol from ending is A, really DFA looks like very difficult. If anybody trying for this problem, A plus B power star A followed by A plus B square, which means third symbol from last is A. If you want to design this problem, do you know how many states requires? Minimum DFA, how many states requires? 2 power 3, because third symbol you are looking, third symbol from last is A. So 2 power 3, 8 states. If I am looking for 10th symbol from last, 2 power 10, 24 states are really look so difficult to express, correct? You cannot show in a few minutes. But if you want to design NFA, so easy. Look at that minimum NFA, how can you design? The last, third from last, right? So before that, any sequence, that's like A plus B whole star. And third last, we assume this third last is A, and second last is anything, and last symbol is anything. This is how you represent NFA, and just with 4 states, which requires 3 plus 1, because you're looking for the third symbol from begin or end, just 3 plus 1, 4 states enough, correct? So which is the better, which is easy to represent? NFA is easy to represent than DFA. In such cases, NFA would be preferred than DFA. ऐसा नो, यही पर बहुत इजी लगता है कि वो डिजाइनिंग बहुत इजी है कंपेयर टू DFA. अगर DFA डिजाइन करना है इनके लिए, third symbol from last is A. You need to track like anything. Look at that. This you must assume, you need to remember last all symbols, right? If it is not A, just you can keep the self loop, that's okay. B, and it takes, this is the third symbol, right? Now you need to track everything here. A or B, you have to look at everything. This really takes so complicated. See, these 8 states would be very hard to design. Yes or no? Third last, that means if this is the third last, then second and last, all of them you have to track. This is ends with AAA concept. This is ends with AAB concept. This ends with ABA concept. And this is ends with ABB. In all of them, the third last, if you look at all of them, the third last is A. So this 4 states will make final, and you will track all the last 3 symbols, right? If the third last is B, you are not going to track, correct? So now this is how you can get 8 states, and you need to cover up all the missing transitions. AB covered, AB covered, AB covered, AB covered, and here the one more A comes, you can stay here because 4 A's also equal to 3 A's, and last 3 symbols only you are going to track. AAB, if one more A comes, you can go here because last 3 symbols become AAB, and one more A comes, the last 3 symbols are ABA. And if B comes, after AAB, if B comes, last 3 symbols are ABB. You can come here. Okay, after ABA, if A comes, then BAA we are not tracking, but we are tracking for AA. Where is the AA? This is the AA. Of course, remember that the last, what is that? Last 3 symbols, in that last 2 symbols only will see the A, and third symbol is not A. So you can keep as simply AA. This is AB, and this is just A. Before that, we are not tracking anything. You can go to the last 2 symbols because third symbol from ending is B, so we are not tracking it. So you can go there. Here from here, if one more A comes, you can go there. And if B comes, then AB, that you can go here. And after ABB A comes, you can see that after ABB A comes, then in last 3 symbols, the A was in the last only, so you can go to this state, just this one. On A. On B you can go to this state, and would be really difficult to design DFA. Have you seen? Really, some people cannot understand what I have done because you need to track each and every symbol from every state. Yes or no? The last 3 symbols you are looking for, where is the A, is that third last is A or not. Okay, if third is not A, if the second is not A, then you don't worry about the last that symbols. You see that the BB we don't track it, we are tracking for the A only. So is it really difficult or not? Correct. It's a better method is to design this way. You design this, you can convert into DFA. Everybody agree? So everybody should understand why we prefer NFA. If you have this machine, somehow you can convert this NFA into that DFA with the help of algorithm. With the help of algorithm. Are we ready to see the algorithm now? In some cases, designing DFA could be difficult. Then what you can do, design NFA and convert into DFA. Convert into DFA. So I'm going to show that. Of course, this directly may not come, DFA will come, then again algorithm need to apply to get to this minimum DFA. Okay, now the algorithm is NFA to DFA. Okay, I will design NFA, then how to convert into DFA. Let's take a very easy machine. Any idea what is this machine? Very simple machine. Even if you want to design DFA for this, it will take time for you. What is the machine? Any idea? This machine is ends with a double E, right? 2 consecutive A's. Ends with 2 consecutive A's. And it is NFA or DFA? NFA. Now we will see how to convert into DFA. Yeah, just Karan. Right now there is no information. Please don't discuss anything other than the concepts. Any other discussion, we are always available on Telegram. You can tag us. Please don't disturb these classes because this class will be there forever. Somebody want to watch, definitely they should see the content rather than any other discussion, correct? Now what is the algorithm to convert? So before starting this, let me give an idea. First I'll explain the concept, then I'll come to this conversion. Is that fine? And what is the DFA? We know this is NFA. And what is the idea to get the DFA? First I will explain what's happening here. Any NFA you want to convert into DFA, we are using some algorithm. That algorithm name is what? Subset construction. ये है algorithm का नाम. अब यहां पर देखो, क्यों 5 पैरामीटर्स होता ना, any watch finite automata. Q is what here? This is given or not? This is already given, so everything is given, right? Q is given, sigma given, delta given, Q naught given, F given, everything is there here. These are all known, right? These are all known. What you don't know? This thing. So now here set of states is what? Q. Is this correct? Set of states in which motion? N of A. Sigma alphabet, input alphabet, you know it. Delta given, that NFA transitions, right? Transition function or set of transitions is also given. And Q naught, you know, initial state of N of A, it is given. You don't need to find out. F, set of finals, all are given. Set of finals in N of A. But now we don't know what is DFA, correct? The name itself says subset construction algorithm. यहाँ पर जो set of states of DFA हमको चाहिए, right? Set of, we don't know what is this. Set of states of DFA. We don't know. We have to find out. And sigma same. Sigma is same. Right? It's the same exactly, no change. And delta will change, so we need to find, so let's say delta dash. That's a transition function of DFA. And we need to find what is it. We need to find, and Q naught is exactly same. And F, we need to find what is F dash. If you can find these 3 parameters, then your DFA is over. Yes or no? Who are the states of DFA? What are the transitions of DFA? Or what are the finals? Because initial state exactly same as NFA and input symbols exactly same. Everyone agree? Right? Now, what are the states of DFA? To understand it, let me help you with the example. Suppose I have, how many states we have here? 3 states, right? So can I say that Q is equal 1, 2, 3? This is NFA, right? And in DFA, assume that it's a Q dash. Q dash is equal to 2 power Q, which is same as power set of Q. It is same as, you will have empty set, you will have only 1, you will have only 2, you will have only 3. You can have the state name is 1, 2, 1, 3, 2, 3, total 8 states you will have. Every subset is going to be the state. Here state is 1, 2, 3. But here the states are empty set, only 1, only 2, only 3, only 1, 2, only 1, 3 together, and 2, 3 together. The subset, right? How many states we can have in DFA? Equivalent DFA. यहाँ पर 3 state है in NFA में. DFA में every subset of Q will act as a state. Is that clear? Every subset of Q is state of DFA. You got a relation? That's what we call subset construction. यहाँ पर state मतलब वहां का क्यू है उनकी सबसेट्स लेके हम स्टेट डिजाइन करना होगा. एवरी स्टेट दैट लुक्स लाइक सबसेट ऑफ द क्यू इज अ सेट ऑफ स्टेट्स इन NFA. Everybody clear? So now if you want to know the definition of set of states of DFA, how do you answer? It is nothing but 2 power q. So if you assume this is a q dash, that is set of all subsets of q. Q is already given as the NFA states, set of states on NFA. Any doubt? A good Pratik. So this very important theoretical concept is very important. Okay. So now we got to know what are the states. Now transitions, how to find out. So can we work on with the example now? So almost every parameter is covered except the 2 parameters. 2 parameters we can understand with an example. Now you got to know that every subset can act like a state. So I can directly design the DFA table. Before that, NFA table. Can you help me? The NFA table, initial state is 1, 2, 3 and A is input, B is also input. 1 on A you have 1 comma 2. 1 on B, only 1, and 3 is the final, right? You keep a star here. And 2 on A is only 2, sorry, only 3. 2 on B, nothing, so pi. 3 on A, nothing. 3 on B, nothing. Any doubt? How to design an NFA table? This is already given. This is given because the diagram is given. Both are same, correct? So just convert into table so that you can copy paste. There are 2 ways to design a DFA. Remember, there are 2 ways to design. You can start blindly or you can start with the initial state of NFA. Is your choice. So you can do 2 ways. One is taking all the subsets. Other one is taking only useful subsets. Because sometimes some subsets are useless. So directly you can start with the useful one. So I'm going to do 2 things here. So first I will blindly, method 1, I'll take blindly all of them. Okay, I'll take all the subsets first. Okay, the delta dash and DFA delta. Okay, A and B. So you have pi, you have only 1, you have only 2, you have only 3, you have 1 comma 2, 1 comma 3, 2 comma 3, 1 comma 2 comma 3. So all the subsets we have taken, you can always design a DFA. Just copy paste the concept because very easy when you do this kind of method. But method 2, you need to be very careful. Method 2 takes time to design. Method 2 also I'll design later. Can you help me? Pi means no need to look at any row because pi is nothing but it's an empty subset. It's just like a dead state. If you have a dead state in DFA, it will come out. If you don't have, that will be deleted. So pi on A is pi, pi on B is pi. Now this 1, 2, 3 is exactly same as this 1, 2, 3. You can copy the entire row as it is. Okay, I'll give you algorithm from here. One row, just copy paste. This is a 1, 2, 3. All these 3 rows copy here as it is. 1 on A, 1 comma 2. 1 on B, 1. 2 on A, 3. And 2 on B, pi. 3 on A, pi. 3 on B, pi. After that, the 1 comma 2, that means the row 1, row 2 on A, just do the union. So the algorithm I'm trying to mention, 1 comma 2 on A. If you want to do it, look at how to do it. You want to find in the delta dash 1 comma 2 on A. What you have to do, delta 1 comma A union delta 2 comma A. This is given, this is a NFA transition, NFA transition. Now this is a DFA transition, yes or no? अगर आपको DFA ट्रांजिशन कंप्यूट करना है तो NFA का ट्रांजिशन लेके यूनियन लेना होगा. तो आपको पता है 1 comma A, 2 comma A, sorry, already there are 2 things here, right? Just take this 2 and do the union. That is the meaning. It's NFA table which is given already, and if you want to compute the 1 comma 2, it is a state in a DFA, right? On A. So 1 comma A, 2 comma A, you need to do the union. Yes or no? 1 comma A, this is a delta dash. So delta 1 comma A union delta 2 comma A. That's all. Can we do that now by looking at the entry? Come here and just do the union. 1 2 on A means 1 comma A union 2 comma A. So 1 2 union 3, 1 2 3. Understood how to get it? 1 2 3. And B also same concept. Just do this union. 1 comma B union 2 comma B. So 1 union pi is a 1. Similarly, every other 1 3 means 1 union 3. So just combine these two rows. 1 2 union pi, 1 union pi. So you will get 1 comma 2 and then pi. Sorry, 1 union pi is sorry 1, right? I'm very sorry. 1 union pi is 1. Okay, 2 3 means just combine these two. 3 union pi is 3 and pi union pi is pi. And 1 2 3 means 1a union 2a union 3a. That means these three you have to combine. So 1 2 3 union pi is a 1 2 3. And then 1 union pi is 1. Is it clear? So can you compute any transition now? Got it? बहुत easy यार, ये एग्जाम में नहीं करना है. Just you need to aware, because if it given for 2 states, you should be in a position to convert very immediately. In exam, you should never use this algorithm except the concept. Concept I'll discuss at the end. What is required for the exam? Okay. Now transitions are covered. Delta dash is over. Now final states. Can you see final state here? Who is the final state? 3 is the final in NFA. If any subset has a 3, can you see that 3 is here and 3 is here, 3 is here, 3 is here. Just make them as final. Wherever you see the 3, just make them as final. That's all. Now DFA is over. DFA is over. But what is the problem here? All the states may not be reachable from initial state. Who is the initial here? 1 is the initial. So from the 1, all the states may not be reachable sometimes. So you can see 1 on A, you can reach 1 2. So this is useful. 1 on A, B is 1. And then we will go to 1 comma 2. 1 comma 2, 1 2 3 is reachable. So 1 2 3 is useful. 1 is useful. And 1 2 3 when we go 1 2 3 1. So nowhere only 2 did not come. Only 3 did not come. Empty set did not come. So look at that. So many states are useless. Yes or no? Now instead of doing this, you can do method 2. What is that another one? Method 2. What is method 2? You can only take the useful states. Of course, no guarantee of minimum DFA, but take only reachable states from the initial state. You can start with 1 directly rather than everyone. So now what you can do is A, and B. You can just start with 1 and 1 will tell us which states are useful. 1 on A, you can copy paste from here because same thing comes, right? 1 on A, 1 2. That means 1 2 is useful. 1 on B, self loop. Correct. Now among these 2 states, 1 already covered. So 1 comma 2 is a new state. So 1 comma 2 we need to cover. So you can look at 1 2 A, you got a 1 2 3. There is new state is created. New subset means new state, and 1 already is there. So we'll go there. Now new state is 1 2 3. Take 1 2 3. 1 2 3 on A, we already got it. 1 2 3 and then 1. That's it. And who is the final? The 3 in this subset is there, so we are going to take 3 as a final. And luckily we got the minimum DFA at this point, but not always. Did you see how many states we have saved? Out of 8, only 3 are useful, and remaining states are actually not reachable from initial one. That's why they are all deleted. So you can start with the initial state of DFA to understand what states are reachable, so that you can save a lot of time in construction of DFA. And this one blindly takes all the 2 power q subsets and it will design. Right? Of course, both are DFAs, but this DFA called as complete DFA because every state is reachable from initial state, and this method may not design complete DFA, but it is DFA. Got it? So many people directly do this one, but in the exam they may also give. So look at that. Some states are not reachable from the initial state. Delete blindly, then you will get this one. And this may or may not minimum DFA. Again, you need to apply the minimization algorithm to see the minimum DFA, which could take much time while converting from NFA to DFA. In case if you want to design a DFA for this, I'm just helping you. You have initial state is what? 1. And I'm just combining, I'm not putting a bracket. That's not required. 1, 2. Assume this is a set. And 1, 2, 3. 1, 2, 3 is a final. 1 on A is a 1, 2. 1 on B is self loop. And 1, 2 on A, 1, 2, 3. 1, 2 on B is a what? On 1. And 1, 2, 3 on A self loop. And on B 1. That's it. This is a ends with a double A concept. Otherwise, by looking at this also you can design. Along with this, there are unreachable states are there which are unreachable from initial state. So they are useless anyhow, you can delete blindly. So now in this method, there is a very important theoretical concept. Now you understood what is delta dash. Delta dash, very easy to compute. And f dash is, if any state of f present in a subset, that subset will become final. Okay. Something I can say, x such that if final of n of a belongs to x. What is x? X is subset of Q, that is state of DFA. Of course, short form I'm writing in mathematical form. You can make every state which is final, where in that set, in that state, set both are same here, because every state looks like set. So in that set you will see the final of n of a, then that set you will make as a final in DFA. Okay, so very interesting mathematical notation, that's fine. So now you will get some theoretical questions in the gate, like you have n of a, you have DFA, and you have minimum DFA. My question is, if I have n states here, can we design always with 2 power n states? Yes, correct. You can always design 2 power n states, but minimum DFA, how many states you can? If there is always DFA with 2 power n states, 2 power n states, DFA always exists, which is equivalent, right? Using algorithm. Then minimum DFA, how many states? Either this 2 power n or less than this. So at most 2 power n states guaranteed. So in the exam they will ask directly from here to here, if n of a has n states, how many states in minimum DFA? You should say at most 2 power n. Correct? So this is the theoretical question many times in the gate. So far I think 4 times happened in the gate. Here, if n states are there, minimum DFA, how many states? You should say at most 2 power n. At most 2 power n means less than or equal to 2 power n. Yeah, within 2 power n, correct. Yeah, let's move into NFA with epsilon moves. Now you understood NFA to DFA. This is without epsilon moves we did. Even if you take NFA with epsilon moves, NFA without epsilon moves, you will get same answer what you have seen so far. Without epsilon moves and DFA and the minimum DFA. Look at this again, the concept. Okay, very interesting. Okay, so now let me take this NFA, DFA, minimum DFA. Now they may ask from anyone, both are NFA, right? यहाँ पर both are NFA है, तो NFA से minimum DFA पूछेंगे, सेम आंसर होगा. आपको ऑलरेडी पता है रिलेशन, राइट? यहाँ पर n स्टेट्स होगा, कितने स्टेट्स होगा यहाँ पर? 2 power n, एंड यहाँ पर at most 2 power n. And NFA with epsilon moves also you can convert to NFA without epsilon moves, n states only. That is the reason now anybody ask NFA to DFA, minimum DFA, you will say if NFA has n states, minimum DFA has 2 power n states, you will always answer the same way. Got the point? Because there is another algorithm to convert NFA to NFA just with n states only without reducing. And NFA to DFA, we have another algorithm, subset construction. If you have n states, you can always design 2 power n states DFA. And to convert, there is an algorithm, minimization algorithm, that converts to at most 2 power n states by combining. Got it? Very interesting relation between these machines. Okay. Now they may ask NFA or NFA without epsilon, with epsilon, the same answer should come out, at most 2 power n. In future, they try to confuse with this machine. NFA with epsilon moves has n states, then how many states in minimum DFA? Same answer, no confusion at all. Okay. So sometime we'll discuss NFA with epsilon moves. In some other time, we'll convert even directly to DFA. So we have this algorithm left to discuss in future. Okay. Take the heading NFA with epsilon moves. We have not discussed it, right? A very special machine. NFA with epsilon moves. What is the delta? Q cross sigma union epsilon maps to 2 power q. Okay. Let's look at the basic concept now. Who is called as NFA with epsilon moves? Let's try with an example. Do you know DFA? Let's take ends with A. Have you remembered ends with A concept? Is this ends with A? We know this is a DFA, right? And ends with A you can also design another way, right? Correct? And why do you want this way? And I can also design another way. This is NFA without epsilon moves. Now there is a special machine I am designing. Just look at it. A comma B. Assume it is epsilon. Okay. Now look at, is this DFA? No. Is this NFA without epsilon moves? No. Now my question is this NFA? Can I call this machine as NFA? Yes. Can I call without epsilon moves? Yes. Can I call with epsilon moves? Remember, this is also NFA with epsilon moves, but epsilon moves not there, because for epsilon, zero transition definition exists. The NFA says that I may have 0 or more. For epsilon, from every state there is no transition, that is also NFA. So this machine is a DFA. This machine NFA without epsilon moves. This machine is NFA with epsilon moves. And this machine is not a DFA because DFA definition failed, and this is NFA without epsilon moves, but also NFA with epsilon moves. And now you may wonder how it can be. I can't see epsilon. Still you are saying NFA with epsilon, because you are looking at English word, not technical word. This definition is satisfied by all the three. I'll show you soon. This is not a DFA and not NFA without epsilon moves, but it is, you see that explicit transition here, it is only NFA with epsilon moves. Now what you have to believe is this is also NFA with epsilon moves. If I show the definition of DFA and NFA for this, will you believe that all the three are NFAs with epsilon moves? That's the main target for us. Got it? बहुत लोग को ये कंफ्यूजन होता है, ओनली दैट इज एनएफए विद एप्सिलॉन मूव्स अज्यूम कर लेते, ये दोनों नहीं करते तो वहां पर उनको कॉन्सेप्ट्स क्लियर नहीं होता. सिर्फ वो इंग्लिश लाइन नहीं है, वो टेक्निकल कॉन्सेप्ट है. ठीक है. ठीक है. नाउ आई एम जस्ट शोइंग इट ends with A, right? Now I'm trying to show, let's say this is 1 and 2, and we know DFA, right? This is, I'm trying to prove it DFA. I'm trying to prove NFA without epsilon moves. I'm trying to prove NFA with epsilon moves, because all the three definitions preserved by this version. Okay, so now delta Q cross sigma maps to Q is a DFA definition, and delta Q cross sigma that maps to 2 power Q is NFA definition without epsilon mouse, and with epsilon mouse is the definition is here. So I'm trying to prove all of them. Let's look at. If it is DFA, then domain is just 1 to 1 comma A, 1 comma B, 2 comma A, 2 comma B. That is Q cross sigma. This is a domain, right? Codomain is just 1, 2. Now look at 1 comma A is 2, 1 comma B is a self loop, and 2 comma A self loop, 2 comma B 1. So this is the DFA mapping, and this also preserved here. 1 comma A, 1 comma B, 2 comma A, 2 comma B. Domain is same for even NFA without epsilon mouse, and codomain is empty, only 1, only 2, and both is 1 comma 2. This is a codomain. Now 1 comma A is what? Is a 2. I hope it is visible. 1 comma A is 2. 2, and 1 comma B is 1, only 1. 2 comma A is only 2. 2 comma B is only 1. So it's a definition satisfied. And how it satisfies this NFA with epsilon mouse? Look at this domain is slightly different now. Domain is 1 comma A, 1 comma B, 1 comma no input. 2 comma A, 2 comma B, 2 comma no input means epsilon. So now we will have the 6 pairs in domain instead of 4. And here you will have 5, only 1, only 2, 1 comma 2. The 1 comma 2 is the Q. And now look at how the definition satisfied. 1 comma A, do you have a transition? Yes, that to 2. 1 comma B, self loop. And 1 comma epsilon, no transition, so empty set. Did you see that? 1 comma epsilon, empty because no transition. If you have a transition here, let's say on epsilon, then you can give 1 comma epsilon is 2, but you don't have that transition, right? And 2 comma A, you have a self loop. 2 comma B on 1, 2 comma epsilon is a pi. Did you see the definition satisfied by all the three? That's why it is a DFA, NFA. You can say every DFA is NFA, but which NFA you are not talking all the time. So that's okay. Here बहुत सही है, and every DFA is NFA. Which NFA you wanted? Both fine. Not clear? So this is a very important notation. So that's what I'm trying to say. This is NFA with epsilon mouse. This is NFA with epsilon mouse. This one is NFA with epsilon mouse. When you look at the algorithms, you will see, look at here, NFA with epsilon mouse, NFA without epsilon mouse. And when you learn the algorithms for the semesters, you can match these things, okay? Which are by definition, look at. Every DFA is NFA by definition. Yes or no? These are by definition. You no need to apply any specific algorithm because by definition itself is algorithm. Yes or no? You no need to convert them because every DFA is NFA and every NFA without epsilon mouse is also with epsilon. But this side you have explicit algorithms. Are you getting? This side you will see a special algorithm. Because you cannot assume every NFA with epsilon mouse is NFA without epsilon mouse. That's why you need to convert. And every NFA without epsilon also, with epsilon also you can convert into DFA using algorithm. Direct algorithm is there. And this side also direct algorithm. Okay. So total 3 algorithms you should learn for the semester, but GATE exam 1 algorithm would be fine because they will not ask this kind of questions for the exam point of view. Okay. Is that clear? Why we say DFA is equivalent to NFA? Which NFA we no need to say it because all of them will satisfy in NFA. Because of this reason, every DFA is equivalent to NFA. Every NFA is equivalent to some DFA. Okay, now we'll learn some important concept in NFA like finding epsilon closures. This is a gate model question. Epsilon closure of any state. Let's say Q is a state. What is the epsilon closure of Q? Example: A, B, and C. Can you see that? You have, of course, final state I don't care because I'm applying for epsilon closure. I'm not asking about what is the language. Okay, यहाँ पर हम सिर्फ epsilon closure definition पढ़ने वाला है हम. ठीक है, यहाँ पर आपको एक और concept चाहिए मुझे. ठीक है, let's talk about this one. Now यहाँ पर इस ट्रांजिशन के ऊपर कोई सिंबल नहीं है. इसका मतलब क्या है? इसका मतलब है यहां पर कोई सिंबल नहीं है. मतलब कौन है यहां पर? एप्सिलॉन है. ये भी याद रखना. इट्स अ बेटर टू प्रैक्टिस विदाउट राइटिंग एनीथिंग, तो आपको बहुत क्लियर होगा यहां पर कौन होगा? एप्सिलॉन. अगर ट्रांजिशन दैट एज के ऊपर कोई सिंबल नहीं लिखा, इसका मतलब एप्सिलॉन ही होता है. ठीक है, जैसे 1 to 2 आपको दिख रहा है, कोई इनपुट सिंबल नहीं है, इसका मतलब 1 ऑन एप्सिलॉन इट मूव्स टू 2. इसका मतलब ये होता है मीनिंग. तो अगर कोई भी पूछा है डेल्टा 1 कामा एप्सिलॉन, आपको 2 देना होगा, क्यों? 1 ऑन एप्सिलॉन 2 पर है. ठीक है, डन. ये एनएफए विथ एप्सिलॉन मूव्स है. इसको डीएफए नहीं मानते हम, इसको एनएफए विदाउट एप्सिलॉन मूव्स भी नहीं मानते, क्यों? एप्सिलॉन क्लियरली दिख रहा है. ठीक है, अब बताना मुझे एप्सिलॉन क्लोजर ऑफ क्यू, इनका मीनिंग होता है you need to find all the states which can halt from Q by reading epsilon. That means set of all states reachable from Q without reading any input, without reading any input. इसका मतलब by reading epsilon. Without reading anything means by reading epsilon. अब ये बात आएगा epsilon closure of 1. Now from state 1, what are the states you can reach without reading any input? So 1 to 1 by definition, yes or no? 1 on epsilon, can you reach 1? Obviously. 1 on epsilon, can you reach 2? Look at that. Directly there is a transition, correct? Yes. 1 on epsilon, can you reach a 3? Of course, indirectly. 1 on epsilon 2, 2 on epsilon 3, and that means 1 on epsilon you can halt at 3 by reading string epsilon, but there are 2 transitions to understand, correct? So can I say 1, 2, 3? Can I say 1, 2, 3? Now similarly, can you compute for epsilon closure of 2? By definition, without looking anything, 2 can reach 2 by definition, yes or no? If you ask from 2, 2 itself is reachable, right? अब यहां से देखना होगा 2 to 1 कोई epsilon path है? Path transition 1 2 के बाद भी मिल सकता है. 2 on epsilon 1, 2 on epsilon 3. So आप you can reach same, both are same, 1 2 3 again. Correct? Now try to find epsilon closure of 3. You will get an idea what is epsilon closure. 3 to 3 by definition, but can you go to 3 to 2? No path to the 2 without reading anything. 3 to 1, you can't go back. So only 3. Got clear? Can we practice on this? It's one of the gate model type question. आपको practice करना होगा gate exam के लिए. What is epsilon closure? You need to find every state that is reachable without reading anything. यहां पर 1 2 3 कैसे मूव हुआ? 1 on epsilon 2, 2 on epsilon 3. So epsilon dot epsilon is epsilon only. Okay, let's practice one more example. Okay, so I hope I have given my transitions. So if I don't write anything, what is the meaning? So this is epsilon, this is epsilon, this is epsilon, this is epsilon. So remember that the yellow colors actually not required to represent here on the machine, in the machine. I don't have epsilon, I don't have input means I have epsilon there. So can you find out epsilon closure of 1? Epsilon closure of 2? कभी कभी साइज भी पूछेंगे एग्जाम में. साइज मतलब हाउ मेनी स्टेट्स इनसाइड द एप्सिलॉन क्लोजर. साइज भी पूछा है तो बहुत इजी होगा एग्जाम के लिए. न्यूमेरिकल आंसर टाइप एप्सिलॉन क्लोजर ऑफ 1. तो बाय डेफिनेशन you can write themselves, right, without looking anything. Just write 1 here and next find out 1 to 2, yes. 1 to 3, yes. Epsilon epsilon. 1 to 4, yes, correct. So all of them. Now from 2 without looking at the machine, 2 and 2 to 1, just like this. 2 to 3, 3 to 1. 2 to 1 possible, 2 to 3 possible, but 2 to 4, can you find out 2 to 4? 2 to 3, 3 to 1, 1 to 4, all of them. Yes or no? Again 1 2 3 4, again 1 2 3 4. Epsilon closure of 2, order doesn't matter. 1 2 3 4 you can write. For 3, 3 to 1 possible, 3 to 2 possible, 3 to 3 possible, 3 to 4 possible. Again all. Right here 4. Epsilon closure of 4. 4 to 1. So by the way, first write 4. Okay, then we'll write others. 4 to anybody you are going A and B there. Without reading anything, you can't reach anyone, right? So only 4. Got clear? Great. So today we have learned the differences between NFA and DFA and epsilon closure of what NFA is. NFA with epsilon moves. Okay. So what is the difference between NFA and DFA and conversion from NFA to DFA? That one algorithm is enough. And if the NFA has n states, DFA will have at most 2 power n states in the minimum DFA. Okay. And then how to find the epsilon closures for any state. So these are the 3 concepts we have understood in this session. Right. In coming session, we'll also look at various conversions, finite automata to regular expression, and many other things are there. Okay. See you in DPP session. So in DPP, we'll be practicing more on this conversions. Okay. I'll be asking directly the exam type of gate questions, so you can practice the DPP. So DPP 7 is going to be today, and we have completed NFA to DFA conversion. And next class you can see finite automata and regular expressions. This is a very important topic because every year one gate question coming on this concept. So you can attend the next session as very important. Can we move further? Thank you so much for joining today. In case if you are very interested to study with us, then you can also attend this kind of scholarship test to avail 100% the scholarship on the subscription. The top 5 rankers will get the 100% scholarship, so that you can join an academy freely and you can start learning from us. And this exam is duration is 30 minutes and 11 AM on 22nd June. So you can apply to this test to avail the scholarship, and many batches have been started soon recently. So you can attend these batches if you have already enrolled. If not, you can enroll and start learning from us. And test series is already launched, and this is at 1,499. If you're an academic student already, then this is absolutely free. You don't need to purchase the test series. But if you're not an academic student, you want only test series, yes, you can use the CSDA code to avail this offer. Okay. CS test is series is 1,499, and if you also want data science, you have to purchase separately. This is a CSDA. But if you have taken an academic subscription, both test series are absolutely free. You don't no need to purchase of these 2 test series if you are already an academic student. Okay. So if you want to follow me, please use this link and click on follow button once you visit my profile. Okay, thank you so much for joining today. See you tomorrow. Tomorrow we have the class at 6 PM again, and tomorrow we'll be having very important session. Okay. Thank you so much.